everybody, get ready to do lesson 11.5 of Pre-Algebra Math. Part 1, Part 2 is available here to see now. And today we're going to do 11.5 interpreting data. We got a 40-point classwork sheet today, and then we have 0 points here for notebook entries. Here is your standard up here, grade 9 through 12, SM&D, 6, sampling, and probability. Teachers, today's bell work is multiple choice for number 1. Which question is not biased? Students answer that. And then scale problem here. Use the given map distance to find the actual distance here. So the actual distance, 1 centimeter is 25 kilometers. So how far is 5 millimeters in kilometers? Okay. Give your students about 5-6 minutes. Okay, welcome back. For solution is B. Do you support the governor's proposal to reduce state taxes? Which is not biased. The rest of these are biased here, by the way. And then for number 2, here is your conversion factor here to convert millimeters into centimeters. It's 0.5 centimeters. And so you have 1 centimeter, 25 kilometers, and it comes out to 12.5 kilometers for this distance here. And those are your solutions for work. Into our lesson today. You identified by surveys. You will make conclusions about populations using surveys. TVs, networks rely on surveys. In a survey of 5,000 randomly selected American households, 780 of the households watched a certain program. Of all American households, how many watched the program? This is a question that we aim to throughout this lesson here. Example 1, making a population prediction, 105 million households. To estimate the number of households that watched the program described above, follow these steps. Find a percentage of households in the sample. So you have 15.6% of the households. Find 50.6% of the total number of households in the United States. So that is 16.4 million households watched this program. So that would be the solution to that question. Into our first guided practice. In a survey of 5,000 randomly selected households, 460 households watched a certain program. Of all American households, about how many watched the program for our guided practice. And then for your students, independent practice here, you have plus or minus 7% of these voters, blah, blah, blah. So go ahead and answer that. Let's get our solution up here for our guided practice. Find a percent of households in the sample that watched programs. So 460 out of 5,000, say, is 9.2%. So 9.2 of 105 million is 9.7 million households. So that'd be the way that you would predict the amount of households from a sample. Margin of error. When a survey sample is only a portion of a population, different surveys of the same population may have different results. For example, one survey might find that 32% of the population uses a cell phone. Another might find that 36% does. The actual percent might be 33%. You have a margin of error here situation. So margin of error of a random sample defines as interval centered on the sample percent on which the population percent is most likely to lie. For example, a sample percent of 32% with margin of error plus or minus 5% means between 27 and 37%. So you have a margin of error here. so it's plus or minus 32. And so to diagram that margin of error, 27, 37, you have a spread here of like 10. You go from 27 to 37, so you have a spread here of 10. So, and this is how you figure that. 32 minus 5 is 27. 32 plus 5 is 37. So again, you got a spread there of 10. Okay, so example 2 here, interpreting a margin of error. Random sample predicts that a candidate will receive 52%. Candidate A, candidate B will receive 48%. Margin of error is plus or minus 3. Can you predict who will win the election using a margin of error now? We can say candidate A will get 49% to 55%. Candidate B will get 45% to 51%. So what does that mean ultimately? You can conclude that candidate A is likely to receive between 49 and 55% of the votes. Candidate B is likely to receive 45 and 51% of the votes. Because the intervals overlap for the two candidates, you cannot predict which candidate will win the election thanks to margin of error. So hair color, here's our next guided practice here. A town has 5,000 residents. Survey finds that 81 residents out of its random sample of 625 have red hair. The margin of error for the survey is plus or minus 4. Find the interval in which the total number of residents with red hair is most likely to lie. And then down here, this is your students. What is the margin of error for the survey here? Blah, blah, blah. So let's respond to our guided practice here. Find the percent of residents in the sample who have red hair. So we have 12.96%. So plus or minus 4. So we go from here to here. Total number of residents in town. So it'll be 448 to 848. So between 448 and 848 residents in the town have red hair. That would be how you would predict that from that sampling. And now, so what does all this mean? Summary of data analysis. When reading results of survey, consider the following: identify population and sampling method, determine whether a sample represents population, whether the survey questions are biased, identify margin of error, determine whether any data displays are potentially misleading, and decide if the conclusions are supported by the data. So that's a nice little summary there of what this lesson was. And that's it. 11.5, part 1. Part 2 is available here, as long as all of your other course materials. Thank you.